Hello everyone, welcome to the third session on the same topic, vital statistics, presented by Shantala Kulkarni, Department of Statistics, Gokte PU College of Belgavi. Now, from the previous class, we've already dealt with so many different formulas on fertility. So today we'll be dealing with the reproduction rates. The two reproduction rates are gross reproduction rate, GRR, and net reproduction rate, that is NRR. Now, why do we want to use these reproduction rates? Since clearly mentioned here, the fertility rates are unsuitable for giving an idea of the rate of growth of population because they ignore the sex of the newly born children and their mortality. If the majority of these births are boys, the population is bound to decrease, while the population will increase if the majority of the births are girls. So what is the meaning of this? So it very much says that only if girls are born, the fertility rate is going to increase. So here, if the birth of the boys are more, naturally the rate, the fertility will be ignored. So to exclusively measure the rate of growth of population, these are the two formulas we'll be using under reproduction rates, that is gross reproduction rate and net reproduction rate. Now let us see what is gross reproduction rate. Gross reproduction is clearly defined as GRR is defined as the sum of annual WSFR of the entire reproductive span without mortality. Now let me explain what is WSFR. WSFR is women's specific fertility rate. Now to be more simple or to be more specific in the definition, it says that, or I would say that it shows the rate at which mothers would be replaced by daughters and the old generation by the new. If no mother died or migrated before reaching the upper limit of the childbearing age, and that is 49 years, and we computed by the formula GRR is equal to I into summation, where I takes the value from 15 to 49 WSFR. And what is WSFR? Is nothing but women's specific fertility rate. I is the magnitude of the age class, or it's the width of the age group. And WSFR is women's specific fertility rate, and it is given by B divided by P into 1000. Superscript is F and subscript is X. That means females under the birth X and female population under the under the age group X into 1000. So what is the formula for GRR? It is I into summation WSFR, and WSFR is women's specific fertility rate. Now there is one more important thing. Now see, if GRR per woman is 1, it indicates that the current generation of females of childbearing age will maintain itself on the basis of current fertility, but without mortality. So when you're going to calculate GRR, and suppose if its value is 1, it says that the current generation of females of childbearing age will maintain itself, it will remain constant. But if it is less than 1, the population will be decreasing, and if it's more than 1, the population will be increasing. So we have just taken an example of 2010. The estimated value of GRR per woman for India in the year 2010 is 1.2 and varies from 0.9 in urban areas to 1.3 in rural areas. So this is about GRR. Let us see some merits and demerits. What's the first merit? It is useful for comparing fertility in different areas or in the same area at different time periods. That's the first one. The second one, it has an advantage over the total fertility rate because in its computation we take into account only the female babies who are the future mothers. So demerit is it ignores the mortality. All the girls born do not survive till they reach the childbearing age. This is the demerit. Like we really never know that if the girl child is born, she has to survive till her fertility period. That is she has to be alive from 15 to 49. If she is not alive, then there's the biggest demerit. So these are the merits and demerits of GRR. Now let us take a very simple example on gross reproduction rate. So what is the example and what are the things given here? As usual, we have the age, we have the female population, we have the female births. Now the age group starts from 15 to 19, 20 to 24, 25 to 29, so on till 45 to 49. The female population, the first value starts with 1658, then 1212, so on the values are given. Let me just mention the first female birth value. The first one is 19, 70, 98, so on. The last one is 1. How do we find this? The age group is written as it is, then we have the female population, then we have the female births. So what is the formula for GRR? It is I into summation WSFR. So first we need to calculate WSFR, that is a women specific fertility rate, and that is calculated very simply, that is 19 divided by 1658 into 1000, which accounts us to 11.4595. Similarly, we'll be calculating all these WSFR for all the different age groups, and those values are mentioned here. The second one will be 57.755. Next one is 57.988, then comes 40.1235, so on. All these values are calculated. That is, the last column is WSFR. And then coming to the formula, GRR is equal to I into summation WSFR. So I here is the width, that is 15, 16, 17, 18, 19. This is an inclusive class interval, so the width is going to be 5. And summation means we are going to total the values what we have calculated for WSFR. So the total is 200.2729, and then we substitute in the respective concerned values. That is 5 into 200.2729 is 1001.364 female births per 1000. So for every 1000, this is the value. If you want to do it individually, you will be dividing it by 1000 and you will be getting the GRR. So this is a simple example on GRR. Now the second reproduction rate is net reproduction rate. What is net reproduction rate? It is the number of female children surviving till their reproductive ages, or number of female children to one woman as she passes through the childbearing age. Now here same NNR cannot exceed GRR for the reason that in its calculation we also take into account mortality. So both the rates will be equal when all the newly born daughters reach the childbearing age and pass through it. So what is NNR? It is the number of female children surviving till their reproductive ages, or number of female children to one woman as she passes through the childbearing age. Now let us see the formula for this. NNR is computed I into summation WSFR into S. Here again the value is from 15 to 49, that is the childbearing age, where I is the magnitude of the class or width of the class. Then WSFR is again given by female births divided by female population into 1000, which we again clearly mention as superscript F capital B subscript X divided by superscript F capital P subscript X into 1000. And here S indicates survival rates. They are the survival rates. Now let us see the merits and demerits. The first merit, it takes into account current fertility and current mortality. The second one, it will show a tendency of increase or decrease in population. Let us check the demerits now. The first one, it assumes constant rates of fertility and mortality over a generation. In actual life, both these rates go on changing. This is the first demerit. The population of a country may deplete more by migration than by declining birth rate. It cannot be used for forecasting future population. These are some of the merits and demerits of NNR. See, there is one particular note. If GRR per women is greater than 1 and NNR per women is less than 1, then the conclusion, it says that the population is decreasing. If GRR is more and NNR is less, we come to the conclusion that the population is decreasing. Let us check this net reproduction rate by an example. What does the example say? The same thing here as gross reproduction rate, but the only change what you're going to find is an extra column of survival rate. To calculate net reproduction rate, in the question itself, you'll be given the column of survival rate as well. So what are the columns? Age group, female population, female births, and survival rate. So the procedure is very much same as GRR. The first step is you're going to find WSFR. So how do we find the WSFR? That is the first value, that is female births is 1250 divided by the female population 50,000, that is into 1000 we get the value 25. So similarly we'll be calculating all of the values accordingly with the different age group. Then what is the next step? The next step here is WSFR into S. Already the survival rate values are given in the question itself. So when you calculate WSFR, that each WSFR you're going to multiply with the survival rate. Now let me quote that example, or let me tell what those values are. So here WSFR is 25 into 0.9. So that gives us 22.5. Second one, 40 into 0.9, that is 36. These are the values in the last column. These are the values in the last column. The third value is 25 into 0.9, that is 22.5. Again 25.85 is 21.25. 10 into 0.85 is 8.5. 10 into 0.75 is 7.5. 2.5 into 0.7 is 1.75. So in NNR, what do? We have got a special column of survival rate. We calculate WSFR, and that WSFR will be multiplied with the values of survival rate, and we make a separate column, and then we sum up. We add all those values, and when we add all those values, we get 120. Let us apply the formula. What is the formula for NNR? I into summation WSFR into S. So we have already calculated the separate column, that is summation WSFR into S, that is 120. I is the width of the class interval, that is 5 years. So 5 into 120 is 600 female births per 1000 women of childbearing age. Now suppose if you want to calculate this per individual or per woman, NNR is 600 divided by 1000, that is 0.6. You're getting the value as 0.6, which is less than 1. So when we have already mentioned, if the population, when you calculate NNR and if the value comes as 1, we say that the population is constant. If it is less than 1, we say that the population is declining or it is decreasing. And if it is more than 1, we say that the population is increasing. So here children, you'll be getting a question of 5 marks also, or you'll be getting a combination of 10 marks. And when you have a combination of 10 marks, you'll be clubbed with GRR and NNR. So now let me quickly define the definition of GRR, or gross reproduction rate, and net reproduction rate once more. So GRR is the average number of daughters a woman would have if she survived her childbearing age, whereas NNR is the average number of daughters that would be born to a female if she passed through her lifetime. So this is the difference between gross reproduction rate and net reproduction rate. So in this class exclusively we have studied about the reproduction rates. And in the next class, we will be dealing with mortality. Thank you for patiently hearing. Thank you, children.